My name is Martin. I'm one of the product managers for force sensor at the Kistler group, and today I'm going to show you how to preload a piezoelectric force sensor. First question people usually ask me is, why do I need a preload? The answer is because you want to get the best out of your sensor. In the lowest range of a piezoelectric force sensor, the deviations in linearity are the highest. That's why we recommend to preload 20% of the nominal range. Or if you want to measure tensile forces, you have to go even higher up. For example, if you want to measure 30% tensile loads or negative force, then we recommend to have a preload of 50%. So you never operate your sensor below 20% of the nominal range. However, let's focus on the preload itself. The things you need, of course, is a piezoelectric force sensor, in this case a 9021C from Kistler. It comes together with some grease and a bolt, but today we're going to focus on another bolt which is a little bit higher in quality. It is the 9420 that you can see here with a centering sleeve, insulation washers and the nut to tighten the bolt. Then we have the structure to build it in that you can see here. The things that are important to build such a structure you find in the manual with all the details needed, and furthermore you need a cable to connect the sensor to the lab amp, which is here, a tool to tighten the nut and a laptop to see the results when you tighten the bolt. Okay, then let's start. First of all, be sure everything is clean. No grease, no dirt, no dust on the contact surfaces here of the top and bottom plate and the sensor itself. Then you take the screw, the bolt, and you add, if you want, some thread locker on it and you screw it in. The bottom plate. Be sure that on the other side the screw stays a little bit recessed, so it has no direct contact to other surfaces. Like this is okay. Then you just let it dry a little bit until the thread lock is dried. Afterwards, you take the centering sleeve. In this case, it has to be a little bit recessed into the bottom plate. Afterwards, you take an insulation washer if needed. I recommend it, but it's basically up to you if you want to use it. Now we're ready to assemble the sensor. I take the sensor first and the cable, because applying the cable later on is much more tedious. So I attach the cable to the sensor and add it here on my structure. If needed, an insulation washer on top of it and the top plate at the end. Okay. Now our sensor is more or less ready to be preloaded. In case alignment is a topic for you, then you can use the plug of the sensor in order to align, and here in our production we use these two plates and we attach it to top and bottom plate like this, and we are ready to put it into this vise. Now everything is perfectly aligned. In order to reduce the friction and therefore the torsional moment on our structure here and on our sensor, we have to grease the contact surfaces of the nut. That means the thread here and the washer on this side. We can do it with this grease that is delivered with the sensor, the 1063. And we apply a little bit of grease here, like this. And on the contact surfaces here, just a little bit. Put it on here and we apply the screw. As you can see now, I connected my sensor with the charge amplifier, which is the lab amp in this case, and the lab amp accordingly connected to my laptop, so I can see how much force I apply on my sensor. Important here is you set up the right sensitivity. You find it here on the sticker of your sensor. It is the full range which is mentioned here, and you take this sensitivity, put it into your lab amp software, and accordingly you choose the range or the force amount that you plan to apply on the sensor as well. When you've done this, we are ready To preload, I start measuring here on our software, and we apply the recommended 20% of the nominal force, which is in this case 7 kilonewton. Okay, that's it. Your sensor is preloaded and ready to measure. Except for one thing, which is really important. With the bolt that you applied here into your structure, you have a force shunt. That means your sensitivity is reduced by 7 to 8% depending on the bolt you are using. Check out the datasheet on our homepage www.kistler.com, and you're going to see the amount of sensitivity you have to deduct. Afterwards, you put it into the software and you are ready. If you want to have it more exact, send in the device to Kistler and we are happy to calibrate it for you so you have the exact value that you need for measurement. Okay, thanks a lot. Have fun with your force sensor. See you next time.